Hey everyone, I'm Ms. Milkowski, the mathematician, and today we are going to simplify the cube root of 120 over the cube root of 3. All right, so I'm going to show you two ways to do this, okay? And we're going to start with way one, which is kind of like the faster way. All right, so for way one, so we've got the cube root of 120 over the cube root of 3, and we want to simplify it. So remember, one of your properties is very helpful with this. You may remember that the nth root of a over the nth root of b equals the nth root of a over b, okay? So if we've got, in this case, the cube root of 120 over the cube root of 3, okay, we can rewrite that as the cube root of 120 over 3. Now, why might we want to do that? Why might we want to, I used to tell my students, if they're going from this direction to this direction or vice versa, if you're going from here to here, you're breaking it up. And if you're going this direction, which is what we're doing, you're kind of putting it back together. So why would we just want to write that as 120 divided by 3? Well, because 120 is divisible by 3. 3 is a factor of 120, so we can simplify that fraction. We can make our lives a heck of a lot easier. So 120 divided by 3 is 40. So now, instead of this, okay, we can rewrite it as this and then put it as simply the cube root of 40, all right? Which is really easy, okay? So now we just need to simplify the cube root of 40, and that's just going to be 2 times the cube root of 5. Boom. Now I understand I did that very quickly, so if you click up there, there's a video on how to simplify the cube root of 40 that you can watch. But there you go, look how fast that was. We just simplified this to this very, very quickly, all right? So there you go. All right, so now let's try way 2. So let's say you forget your property. Let's say you forget that you can rewrite that as the cube root of 20 over 3, simplify, and then simplify again. And you're like, I don't remember that, I don't know what to do, so I'm just going to do what I remember from class, which is to eliminate the radical in the denominator and go from there. All right, so let's start with that. So the first thing that I'm going to say is just set it up. So the cube root of 120 divided by the cube root of 3. Now, how are we going to rationalize this denominator? Okay, so we know we need to multiply by the cube root. So you remember when you have something like, 1 over root 2. Okay, now remember this is the square root, not the cube root, okay? So you just multiply by root 2 over root 2, because remember that's you're multiplying by 1, okay? So whatever you multiply the denominator by, you have to do the numerator by the same thing, otherwise you change the value of the expression. So we go through that, and root 2 times root 2 is 2, and then 1 times root 2 is root 2, so the answer is root 2 over 2. All right, so now a lot of students mistakenly think, oh, well, I can just do the same thing. I can do times the cube root of 3. Now remember, the numerator has to be the same thing. Okay, but here's the problem. We're no longer dealing with square roots, we're dealing with cube roots. And remember, with cube roots, okay, we have to get groups of 3. So in order to pull one outside, we have to get 3 in the group. So, and by 3, I mean 3 numbers. So it could be 3 2s, 3 3s, 3 4s, 3 5s, depending on what's under there, okay? 3 x's, okay? So I have 2 right now. I have the one that's already here, and then another one that I'm putting in here. So I also need to do a third one. Okay, so I'm going to have to do the same thing up here, obviously. All right, so now let me erase that so I have more room. Okay, so now I'm going to multiply. Now something that I should have done earlier was break up 120, write 120 as a product of its prime factors. So let's just make a quick factor tree here. So I always said, I do love doubling and halving things, but in the case of anything ending in a 0, I always do 10 because that's super easy. So 10 times 12. That's 2 times 6, that's 2 times 3, boom, 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 and then this is 2 times 5. Okay, perfect. So now I'm going to rewrite that as that. So let me, I'll come down here, okay? I'll come down here. So it's going to be the cube root of, and then it's going to be 2 times 2 times 2 times 3 times 5. So 2 times 2 times 2 times 3 times 5, okay? So remember, this is the cube root of 120, okay? Over, all right, so let me just, for visual purposes, I'm just going to put a box around this so we know that this is separate. So we started here, okay, I'll even do an equals up at the top, okay? Well, You know what I mean? I don't want to say that this equals this, but you know what I mean. Okay, and then that's the cube root of 3 on the bottom. And then it's times the cube root of 3 times 3 over the cube root of 3 times 3. Okay, perfect. So now there's another property that you need to remember, okay, which is that, where are we here? Should I do it? I'll do it in orange. That's fine. That the nth root of A times the nth root of B equals the nth root of A times B, okay? Which means that we can just put all of this under this nice cube root, okay, symbol. So the cube root of 2 times 2 times 2 times 3 times 5 times 3 times 3 over the cube root of 3 times 3 times 3, right? We can just combine these. Okay, so I will come up here to do that. Okay, perfect. So now I'm going to do the cube root of, so this is going to be this times this. So it's going to be 2 times 2 times 2 times 3 times 5 times 3 times 3. Okay, because I can just multiply these two together, all right? And remember, I'm not going to actually multiply because I don't want to get really big numbers. I want to keep it written as, whatever the number is, it's written as a product of its prime factors. Then down here, 3 times 3 times 3. Okay, so the cube root of 3 times 3 times 3. Okay, perfect. Now, I'm just going to reorder this so I have 5 times 3 times 3. So instead, I'm just going to write it as 3 times 3 times 5. Okay, just so that the numbers are next to each other. Okay, but everything is still the same. Okay, 3 times 3 times 5. Okay, so I just reordered that, okay? Now I am going to just simplify these radicals. So remember, because it is a cube root, I need 3 in a group before I can pull one out. So right here I have 1, 2, 3 2's. Okay, so I'm going to circle it, and I'm going to pull one outside, and maybe I'll just remove this for a second, okay? So pull one outside, so there's a 2 outside. And then I also see 1, 2, 3 3's, so I can circle it and pull one outside. Remember, it's multiplication on the outside. And then down here, I have 3 3's, so because it's cube root, I circle the 3 3's, cross it out, and pull one outside, all right? So then this has been simplified, okay? So we only have 3 in the denominator now. Okay, so this simplifies to 3 times 2 times the cube root of what's left. Only one thing's left, just a 5. So times the cube root of 5 over 3. Now, here's what I'm going to say. Everybody always says, well, why didn't you write it as 6? I am like really big into keeping things just written as a number written as a product of its prime factors because simplification is just so much more obvious, okay? So instead of writing this as 6, I just chose to keep it as 3 times 2, okay? Because now, look what happens. The 3's cancel, right? And look at what I'm left with. 2 times the cube root of 5. And is that the answer? It is, because we did it way faster, and got the same answer, so that's it. Now, I understand this way is very, very long, okay? However, I think it's important to know how to do it this way in case it's something where it can't simplify nicely to like 40, okay? You may have to use this method. And it's also if you forget that you can simplify and you kind of go about it like, you know, the rationalization of the denominator way, that you know that it can be done. I mean, it might take a little bit longer, but it can still be done. So there you go. Hey everyone, I'm Ms. Milkowski, the mathematician, and I hope you found that last video helpful. If you have any questions or if there are any topics you'd like to see me cover in future videos, definitely let me know in the comments below. Thank you again for watching. I hope you have a wonderful day, and I'm going to leave you with the most important piece of advice I can give you, which is when you're doing mathematics, always ask why.